on, guys? What's going on? So before I hit the start stream button, I was messing around on here some, and I got us figured out. I figured out what it is. So yesterday, we made it all the way to the test immutability for the UserDto file. But the oddest thing was happening. Each individual test was successfully passing, but then when we would run all tests, they would fail. But now they all pass, and I figured out what it was. It was this before each, and it was causing it to fail. So if I just come back here, reset this up, because at first, as you can see here, I commented all these out and removed all these, names right here from, and just made pretty much boring random names just to test around some. But if we go to here and run, it should fail. Username already exists. We comment it out, run the test again, and that's what it was calling it to fail. I don't know why, but that's what was happening. Like, I even was asking ChatGPT, I was like, look, here's the UserDto test file. It is odd because individual tests pass, but when they're all ran together, I get an error username already exists. I gave it the wow, where did the music go? I don't know why that just paused. So I gave it all the test cases, and then I was like, also, here's the UserDto for reference as well. So I gave it the entire code for that. And it says that the error username already exists is likely caused by a conflict between your tests. One possible solution is to isolate the tests by running them independently or by a test runner that runs the tests in separate instances. Another possible solution is to create a user with a unique username for each test that requires a user. Now, I did start with this. That's why I commented all this out. So I was going through and setting up unique. Why is that pausing automatically for? That is the weirdest shit. But anyways, it does it again. I'm going to restart it. Not the computer, not the stream, but Spotify. Anyways. Yeah, that's what I went through. I was just creating, like, except for the first name and last name, I just made these basically all the same. And just created different usernames just to see if that was the issue. The only place I didn't do it was right here since this was the equals. And the toString was just never failing. So, but everything else, yeah, they got different usernames. And it was still failing. It also mentioned the before each. Well, okay, I found out it was the before each and was talking about it. So I was like, you know what? Let's try, for the sake of testing, comment out the entire before each, and we'll just take it from there. Well, as we can see, with the before each, it passes. So, yeah, we're just going to take it out. Yeah, we're just going to take it out because reasons. And I guess usually testing wise, we'd be using this. We would have this set up right here just to use it over and over and over again. But it looks like for these particular tests, that's not the case. So we're not going to worry about it. So we'll have that removed. And we'll just keep trucking forward. And here I was just curious about what the after each was, and it says the after each annotation is a G-unit annotation that is used to indicate that a method should be run after each test method. This method is typically used to perform cleanup tasks after each test, such as resetting. Why did you pause again? No, we're just gonna restart Spotify. That's kind of creepy. And if it still does it, then fuck it, whatever. So, I asked ChatGPT to provide me an example on how to use it. So here's an example on how to use the after each. It says in the teardown method annotated with after each, you can write any code that needs to be executed after each test case, such as resetting variables, closing resources, or deleting test data. This method will be executed automatically by JUnit after each test case. But yeah, so now that we got this all cleaned up, let's go ahead and delete this part here as well. Let's go back to our Trello board, to our, you know what, before I hit here, I am going to go here. I double checked this earlier. Made the last check mark a move on to the UserDto, so I went ahead and checked this, which finishes off completely. And then we'll just throw this over here under review for later. And yep, just go back here. So we have this created. These are our variables that's going to be associated with it. I'm just going to name that as move on to the next thing, just for reasons. Oh my god, of course I'm going to start yawning, ain't I? So yeah, I'm going to have it listed on move on to the next thing, because technically, you know, I'll just do it. Let's see, user repository is next. That time I'm going to try and keep track of things on. User repository. Yep, that's how we're going to move on to things. Okay. So we tested for the immutability. Test immutability. So that's done. Now we're going to test for test immutable null values. So let's go to ChatGPT and let's go scroll back up here and see if we can find it. Let's see here. Test immutability null values. Where is it at? It's in one of these. We'll find it eventually. Right? Maybe. Here's test immutable. Here's test no values. Okay. Test immutable no values. So it'll probably fill it all out automatically. So we're going to test public void. Oh god. Okay. So since we're not using setters, we're testing it through the constructor. Okay. Let's see if this runs. ID must not be null. Okay. So we want it to. Oh, yeah. I see what's missing. So we don't want it to be assert null. We want it to be assert throws. Let's see if this is what we need. ID must not be null. Okay, maybe that's not it. You know what? Let's just start a new conversation. So I think what I'll try to do for this test is see if we can get it to be, if it doesn't just start populating it right here, but for when a null value is try to be set, it throws an exception. That's what I want it to do. Like I want the test to pass by throwing an exception. So let's see what it says here. It says, sure, testing immutability and null values are important aspects of testing data objects. When it comes to testing immutability, we want to ensure that once an object is created, its properties cannot be changed. This can be done by creating an object, modifying its properties, and then verifying that the original properties have not been changed. When it comes to testing null values, we want to ensure that the object behaves correctly when the properties are null. This can be done by creating an object with no properties and then verifying that the object behaves as expected. Here's an example of how you can test immutability and no values for UserDto. Okay. And the test immutability man, say that 10 times fast. In the test immutability method, we create a UserDto object and store its first and last name properties in local variables. We then modify these variables and finally verify that the original properties of the UserDto object have not changed. In the test no values method, we create a UserDto object with no properties and then verify that these properties are indeed null. We then test the behavior of the getFullName method when one or both of the properties are null by expecting a no pointer exception to be thrown. Okay. So we have all those as null. I don't know why. Whatever. Maybe we need both of these at the same time. Okay. So if that's the case, so utilizing your last example about testing immutability null values, rewrite my test case provided. Let's see what it comes up with. Let's see, here's the rewritten test case that tests immutability and no values of the UserDto class. Okay. But if that's the case, then this should error out because we don't have any setters. Yep. Let's see, let's put it at the bottom here. Keep in mind that since the UserDto is immutable, there are no set cases, no set methods when writing out the test case, do not use set methods. I wonder if we would have to do it as, since this is testing each one individually, maybe assert throws the entire user at the same time. Ooh, what is this? That's new. Let's see. Here's an updated version of your test case that tests the immutability of UserDto with no values. Note that I changed the exception type to unsupported operation exception to reflect that setting a value on an immutable object is unsupported, rather than no pointer exceptions. Instead of testing for getter methods returning null, we're testing that attempting to call the with methods to set a value on the immutable object. Okay. Why is this keep pausing for? Is it like broken or something? So we're gonna go back here and we're gonna change this to unsupported. To unsupported operation exception dot class. DTO no. DTO dot. There is, oh shit, it is there, ain't there? Oh, we don't have any methods. Let's try this out. Yeah, because there's nothing here. Okay. Oh, let's see here. Let's see if it understands that. We're gonna do the same thing here. Let's see here. Oh, I think it finally figured out what I was want to do. I apologize for the confusion earlier. Here's an updated version of the test immutability no values method that tests for no values and throws exceptions if a no value is set. In this version, each assert throws method creates a new instance of UserDto with one of its fields set to null. The constructor of UserDto throws a no pointer exception. The test passes. Otherwise, the test fails. This approach ensures that a user cannot create a UserDto with a no value, and that's exactly what I'm trying to do here. Hmm. Perfect. So that, okay. So we're actually going to use this right here, and we're going to throw this in here. Yeah, I'm cool with that. Sweet. All right. Okay, so let's review and see if there's anything else we need to test for the DTO. Otherwise, we might be finished with creating the UserDto and we'll probably move on forward. So let's scroll up here a bunch. Oh shit, that's going all over the place, ain't it? Mm-hmm. Let's see. There's testing no values, immutables again, toStrings. Okay, so let's rewrite a question here. So let's start from up here. So now what we're going to do is we're going to tell everything that we've tested for thus far, and then we're going to ask if there's anything else that we should test for. So get this all typed up. Let's see if what it says. So we provided the names of all the tests that we created. And ooh, what is this? Okay. Let's see here. So it provides us 5 more tests that we could possibly test for, but it says that not every DTO would need to utilize them. It's test for serialization, test if the DTO can be properly serialized and deserialized, test copy constructor, test if the DTO can be properly copied using a copy constructor, test builder pattern, test if the DTO can be properly created using a builder pattern, whatever that's supposed to mean. Then we got test validation, test if the DTO has any validations in place to prevent incorrect data from being set. And then we got test mutability, test if the DTO can be properly mutated when it is supposed to be mutable. Of course, not all of these tests will apply to every DTO. Let's see, with regards to my user DTO, would it be wise or efficient or even effective to test for any of those 5 suggestions that you just suggested? That sounds like a tongue twist all in itself as well. Shit. Let's see. It depends on the specific requirements and use case of your UserDto. For example, if your UserDto is part of a larger system where the uniqueness of the username field is critical, then it would be wise to test for uniqueness. If there are specific formatting or validation requirements for the email field, then it would be wise to test for those as well. On the other hand, if your UserDto is a simple data transfer object and its fields are not critical to the functioning of the system, then these additional tests may not be necessary. In general, it's always good to think about the specific requirements of your system and to test accordingly. Okay. Why did that pause? Why is Spotify like pausing randomly all of a sudden? Hmm. Well, whatever the reason, we'll just keep hitting play. Okay, so mm, here's what I'm gonna do. You provided me with these examples. Please give me a detailed explanation of each one, describing their pros and cons, while showing examples. Because before we move on, this is what we'll go ahead and do. Also, one thing we're going to do is we're going to go ahead and commit this while that's working that out. So we have a UserDto test and a UserDto. Make sure there's like not a bunch of blank lines everywhere. Okay. Let's see. What? Hold up. Oh no, it stopped. Sweet. I'm glad it can do that. Like it's like it runs out of space to what it's supposed to be doing, but then at the same time, if you ask it to continue and whatnot, Like tell where it left off and ask it to continue, it'll keep going. See you. 1, 2, 3, 4, 5. Okay. See here, so we got UserDto test. Hmm? Okay, we'll get to that here in a second. Okay, so let's go over here. Now it looks like these are finished. And we're going to just read over briefly. I asked it for descriptions, pros and cons, and examples of the 5 suggestions for possible test cases. So the first one is for test serialization. It says in this test, you would verify if the DTO can be properly serialized and deserialized. Serialization is the process of converting the DTO object into a stream of bytes so it can be stored or transmitted over a network. And the music stopped again. What the heck? Deserialization is the reverse process converting the bytes back into an object. This test ensures that the DTO can be properly serialized and deserialized without losing any data. Okay, that seems like a legit test. Let's see. Pros ensures that the DTO can be properly serialized and deserialized, which is important when storing or transmitting data over a network. Helps identify serialization and deserialization errors before they are encountered in production. Cons can be time consuming, especially for complex DTOs, may require additional libraries of code. Okay. Does anybody out there just know why Spotify just pauses all of a sudden? You know what? Let's go ahead and play around with okay, before we go ahead and mess with that. Let's see. So I was going to commit my UserDto Java and UserDto test.java files, but received a warning. Variable other can be replaced with pattern variable. This warning refers to the UserDto.java code here. It probably just wants us to like rename it. That's all. The warning is suggesting that you can replace the variable other with a pattern variable to make the code more concise. A pattern variable is a special variable that is introduced in a lambda or similar construct and can be used to refer to the object being operated on. In your case, you can replace other with a pattern variable as follows. Okay, let's see what we got here. So we have if object this returns true, if not object instance of UserDto return false. Okay. Then here's where it changes. The user other disappears. So now, oh, okay. So the difference is right here it says return objects dot equals ID other ID. Here it says return objects dot equals ID. Then it inserts UserDto object ID. So that's really all we got to replace. So we'll just delete that line. We'll just copy this whole line right here. And then paste it over this section. And oh, we have to, yeah, we do have to change these after all too, don't we? Okay, let's go back to our test. Make sure all tests still pass after making that little change. They still pass. Refresh our warning. The warning is gone. Let's see. Inside UserDto.java. Oh boy. I was not expecting that. Uh, we'll just say with this code. Copy, paste. Commit and push. Sweet. All right. Now we're going to go to here. Was that the only changes? Ha! I forgot to click it. So there's that. Now what we got going on here? Oh yeah, we're not gonna worry about these two yet. Okay. So that's pretty much it for the UserDto, but now we're gonna go ahead and go mess around with these 5 suggestions. So let's go back here to our UserDto. We're gonna add optional test. Serialization. All right, and then we're also gonna do optional test. Copy constructor. So let's read about this one. In this test, you would verify that the DTO can properly copy using a copy constructor. The copy constructor creates a new instance of the DTO with the same values as an existing instance. This test ensures that the DTO can be properly copied without any data loss. Pros: ensures that the DTO can be properly copied, which is important when working with DTOs. Helps identify copy constructor errors before they are encountered in production. Cons: may require additional code. And that's fine. And damn, it paused again? I don't know why Spotify keeps pausing for. Okay. Let's see here. I'm actually gonna move this over to here right quick, just so I ain't gotta keep jumping back and forth. What about this test pattern builder? Or it's, yeah, it's optional test builder pattern. Let's see. In this test, you would verify if the DTO can be properly created using a builder pattern. The builder pattern is a creational design that allows for the creation of complex objects by using a step-by-step approach. This test ensures that the DTO can be properly created using a builder pattern. We're probably actually never going to use that, because what we're aiming for, it's most likely never going to be that complicated. So we'll skip that one. You know what, we're still going to put it in here. Yes, I know Spotify just stopped again. So let's check out the next thing. Oh, looks like it's doing its little weird refresh thing. Okay. The next one is test validations. Test validations. In this test, you would verify if the DTO has any validations in place to prevent incorrect data from being set. Validations can include checks for null values, minimum maximum links, and regular expressions. This test ensures that the DTO has the proper validations in place. Pros: ensures that the DTO is able to validate the incoming data, preventing incorrect or invalid data from being set. and leading to unexpected results in the application. And Spotify just paused again. What the hell, man? It can improve the overall quality and reliability of the application by ensuring that the data is always correct and consistent. See, that right there makes me just want to be able to just possibly consider this test as well, just because of that. Cons can add additional complexity to the DTO implementation and testing process, may require additional dependencies or libraries to implement validation checks. Example, let's say we have a DTO representing a user that requires a valid email address. We can add a validation check to ensure that the email address is in a proper format. Here is an example of a test that checks for this validation. In this example, we are testing if setting an invalid email address throws an invalid email exception. If setting a valid email address does not throw an exception, this ensures that the DTO has the proper validation checks in place to prevent invalid email addresses from being set. Technically, we already did that type of testing, so I don't really know if we would need to do that type of validation checks for the DTO. Then we have test mutability. In this test, you would verify if the DTO can be properly mutated when it is supposed to be mutable. This means you would test the DTO's setter methods if they exist. To ensure that they properly modify the state of the DTO, this test ensures that the DTO behaves correctly when it is intended to be mutable. Pros verifies that the DTO can be properly modified when it should be. Helps ensure the correctness of the DTO's behavior. Cons, if the DTO is supposed to be immutable, this test may not be applicable or necessary. So our DTO is immutable. So we are going to add this in there just so we can skip it. So let's go play around with these other two tests. Actually, let's see. Should I test for validation throughout my UserDto if I have already heavily done validation checks in the user.java? Oh, so it looks like we actually got to refresh the screen. Okay, that's what I thought. So it says if you have already performed validation checks in the user class, your UserDto class is simply a data. Oh, and your UserDto class is simply a data transfer object that maps data from user objects. Then it may not be necessary to perform validation checks in the UserDto class as well. However, if the UserDto class contains additional fields or logic that may require validation, it would be wise to perform validation checks in the UserDto class as well to ensure data integrity. In general, it is good practice to perform validation checks in all layers of an application to ensure that data is always valid and consistent. This helps to prevent errors and exceptions from occurring and ensures the data is properly processed and stored. Okay. So let's check out test serialization. All right. So let's start with testing serialization and testing for deserialization if deserialization is needed. Oh, so it's saying implement serializable. Okay. Let's go Google. Ha! Okay, let's check this out. Bam. See, I put, does my Java DTO need to be serializable? You don't need to implement serialize when deserializable for your DTO because it's already handled by Spring Boot. Okay, so we won't worry about serialization. Okay. So in that case, we're gonna skip serialization, deserialization for now, and move towards copy constructor. Hmm. So for testing a copy constructor, your DTO, see, is another way to ensure that the DTO is properly implemented and can be safely used in your application. Here's an example of how you can test a copy constructor in your test class. So we got a original DTO and a copy DTO. Copy DTO refers to the original and then insert equals and it asserts that it's not the same. Okay. In this test, you create an original DTO object and then create a new object using the copy constructor. You then compare the original DTO object and the copy object to ensure that they are equal but not the same object in the memory. If the test passes, it means the copy constructor is working properly. Note that to use a copy constructor in your DTO, you need to define a constructor that takes in an object of the same type as the DTO. Here's an example of how you can define a copy constructor in your UserDto class. The copy constructor simply assigns the values of the fields in the other object to the corresponding fields in the new object being created. So if that's the case, is this code right here only needed just for unit testing? Let's see. The copy constructor and UserDto can serve both testing and non-testing purposes. From a testing perspective, the copy constructor can be used to verify that the DTO can be properly copied, ensuring that all fields are correctly set in the copy. From a non-testing perspective, the copy constructor can be useful when creating new instances of the DTO that are similar or identical to an existing instance. Instead of manually copying each field, the copy constructor can be used to create a new instance with the same values as an existing instance, saving time and reducing the likelihood of errors. Overall, the copy constructor can serve both testing and non-testing purposes, making a useful tool to have in the DTO's implementation. Okay, yeah, that's convincing enough for me. So yeah, we'll go ahead and move on towards that then. So let's go back to our UserDto test anyways. Bam. See here, user copy. We're gonna say copy DTO. Then we got assert equals. Then we got see assert equals. Yeah, that's what we're gonna do. We're gonna call this original, just like in the example. See, this one is the original. This one is the copy. Then we're gonna do assert. Is that not same? And oh, yeah, use a DTO, use a DTO. Okay, okay. But if that's the case, let's just go ahead and paste this here. Yeah, so. Oh, yeah, that's right. I was gonna say, why is that not working? So now we need this one. Here we go. Then we're gonna put hey. Sweet. Alright, let's go ahead and test this. It passes. Now let's go back up here and test all of them, make sure nothing fails. Sweet. Okay. That was simple enough. Now let's go back and start this music again. Like, why does it keep... Spotify just keeps pausing and I don't know why. Alright, let's look towards... delete that test. Okay. What was it? Pattern. Oh, builder pattern. Let's see. Testing the builder pattern involves verifying the DTO can be properly created using the builder pattern. In this test, you would create the DTO using the builder pattern and verify that the, oh shit, that's a lot. And verify if the DTO has the expected values. To test the builder pattern and your user DTO, you can create a new test method like, okay. In this test method, we create a new user DTO instance using the builder pattern and the set values of the DTO using the builder method and the setter methods. Then we verify if the DTO has the expected methods using the assert equals method. If your user DTO class doesn't have a builder pattern implemented, you will need to modify the class and add the builder pattern. Here's an example of how to implement builder pattern in the user DTO. Okay. Oh, I see. It's right here. Then there's another one right here. Oh, there's two things. Oh shit, there's a bunch of things right here. In this example, we've added a new user DTO builder class inside the user DTO class, which has setter methods for all the fields in the user DTO class. The build method creates a new user DTO instance and returns it. We've also added a static builder method in the user DTO class that returns a new instance. Okay. Oh, this is subclassing, isn't it? I know I didn't spell necessary right. Okay, so we're gonna skip that as well since we are immutable. Oh yeah, so I do have it skipped. Sweet. If that's the case, then let's see. We'll run all the tests one more time. All the tests pass. We'll go ahead and commit these then. Let's see. Through unit testing, tested for copy constructor. No warnings, great. Okay, and with that, we're gonna go ahead and end the coding portion of the stream there. And then tomorrow we're gonna be working towards the user repository, which is the next step, I believe. Yep, we're going to be going towards the user repository next. So since that's gonna be all kinds of fun shenanigans tomorrow,